Alright, another tutorial for today. That's it for today, weird. This time, it's assessing logic. So, let's throw in some integer data types first. Integer variables, rather. Alright, so let's explain these two variable types that we're going to be using here. Two values that can represent Boolean values. Well, that's messed up right there. That's supposed to be 1. 1 will be true, B will be false. Alright, and we'll go ahead and exercise some of this code here with AND logic today. Get my string out there, and my AND line, and let's do some AND. Alright, so A and 1, or A and 1 and 1, that will assess to true. Let's go ahead and see it. True. And let me go ahead and put the rest of the code in there. A and B false, B and B false. 0. Anytime 0 is part of the equation, it should evaluate to false. 0, 0. Alright, and the next portion is going to be OR logic, which I'll just quickly copy and paste, as we're pretty much doing the same thing but a different symbol. A true value can happen if the program gets a chance at selecting A or 1. So here, A or A, true, A or B, false. B or B, false. Okay. That's incorrect. That should be true. Let's watch. Yup, just as I suspected. That A or A, true. A or B, true. B and B, B or B, false. So yeah, if you know the program, you should know, even if you made typos, on what would be correct and what would be incorrect. I mean, let's just, you know, do this for the sake of doing that. That's not right at all. Anyways, just to make it more sensible, we'll just do that. And here is another interesting concept here. This is not logic. Well, not is an actual symbol. But anyways, that's just semantics right there. And to demonstrate, we're going to do something that looks like this. A equals and A not A, or yeah, not A equals, oh come on, not A equals not A. So blank space right there. A equals A, not A equals not A. Let's watch. A equals 1, not A equals 0. Because the alternative is 0, because that's B. Let's just throw this one in. B equals B, and not B equals not B. That should equal 0, and that should equal 1, because that's the alternative. See? Not equals means the alternative, equal means it's the assigned value. A equals 1, A equals 0, or not A equals 0, B equals 0, not B equals 1. That makes perfect sense. Now, one more interesting note here I'm going to put. However, the alternative will be 0 for any true Boolean value. And oddly enough, any number that's not 0 is true. So this is going to get weird, but if we do b equals 5, watch this. This is true, that's true, that's true. Ignore this text, because we know at 1 as true, equals true, true, true. It's treating 5 like it's 1. Like, it's true or true, true or true, true or true, true and true, true and true. A equals 1, and not A equals 0. B equals 5, and not B equals 0. Somehow, the 0 got pulled out of nowhere. So this is treating everything just like it's a Boolean. Very interesting. And it could be a -1. The only difference here is that it'll be B will be the assigned value of 1. So even if we go to the negatives, it'll just pull the same shenanigans. Very interesting. But yeah, that's basically the program right there.